Welcome to the Water Resources Database webinar series. My name is Tim Wool. I'm in the TMDL Development section in EPA Region 4. To obtain a copy of WRDB, go to www.wrdb.com. Click on the link on the left that says Download. Scroll to the bottom of the page. You'll see a link that says all current and prior versions of WRDB 6.x can be found here. I'm using build 6.0.028 for this webinar series. You should download this version or higher to make sure that you have all the capabilities and functionality that I'll be demonstrating throughout this series. A little background information for WRDB. It was originally developed in 1994 by Chris Wilson with Wilson Engineering. It was supported by the Georgia Environmental Protection Division, US EPA Region 4, and others. Its primary purpose of development was to manage large time series data for model development and model calibration. The objectives of this webinar are to give you an overview of WRDB capabilities, a quick look at the schema on how the database is structured. We're going to build a WRDB project. We're going to import data both from a web location and from an Excel spreadsheet. We're going to use some of the built-in functions of WRDB to analyze our data using the built-in reports and time series graphs. Just a little bit about the schema, or how the database relates to support tables and other things in there. We need to understand that this structure is rigid. The user does not have the ability to modify that. We would instead have to alter where we place data in these tables depending upon our sources. It's made up of three main support tables: stations tables, P-code tables, and remark code tables. Station tables contain monitoring location specifics: station ID, station name, latitude, longitude, and other ancillary data. P-codes, or parameter codes, contain the descriptor of what was analyzed or what was modeled: dissolved oxygen, chlorophyll A, so on and so forth. And then remark code tables contain flags that are typically generated in the laboratory that indicate that maybe a value was below detection limit or it was calculated from other values. And then we'll just talk about how our working or master tables of data interact with these. And we'll look at more of these as we start populating data into the database. What we're going to do now is we're going to load WRDB, and I'll give you a brief overview of the program. We'll create a project, create a working table, and then import some data. We will now create a WRDB project. To create a project, click on the File menu, New Project. Let's give it the project a name. I'm going to call this Class Example. The description is database used for webinar. Next, we have to configure our project, and the first thing that we have to do is we have to select the database type that we would like to create. WRDB supports three database types that would be stored on your own computer. That would be Microsoft Access compatible file, Firebird embedded, and SQLite. If you have access to database servers such as SQL Server, SQL Server CE, Oracle, or Firebird, or MySQL, you could store your databases on this server. For our purpose, we're going to create one local to our own computer. I'm going to select SQLite because I find this one to be the most efficient one. The next thing we need to do is we need to store our database file, or tables, which are in a file, on our hard drive. WRDB likes to put them in My Documents directory, WRDB, and then I always create a directory underneath WRDB for each of my individual projects. And I'm just going to give this file a name. This is much like you give a Word document a name. And I'm just going to call it Class Example, and then I'm going to click on the Open. So now we have our database table name, where we're going to store it, and our type. WRDB requires master tables for every project. We'll talk about master tables later, but we'll just hit the Create. and it's going to initialize the database file as well as create this master table, and I'm just going to call it master, and then I'm going to say OK down at the bottom. And this is an issue that's in the current version of WRDB. It says it can't find the master table. Just hit cancel here and then just reselect master down here and click OK, and our project will be initiated. So what WRDB is saying now is none of the support tables were found in this project, so it's going to build all of these. So you can see the stations, the P codes, the R codes, the ones that we talked about earlier. So let's just say OK. Now we have created our first project. Notice that the project name is in the upper left-hand corner, and as well as the lower left-hand corner with the description. With our newly created project, we're going to add our first working table. Working tables are subsets of data that we bring into WRDB to work with. You can have as many working tables within a WRDB project as you'd like. So we're going to click on Open Working Table, Create New. I'm going to call this working table Lake Murray. And this is going to be USGS, US EPA, Storette, water quality data. You have the ability to put information in for all of this stuff to keep track of where the data came from. That's all we're going to do for right now. When I click OK, WRDB is going to create a working table called Lake Murray. There is no data in there because the next step that we will do is we'll import data into here. Now that we've created our working table, we're going to use one of the very nice features of WRDB. We're actually going to go to the web and download data to look at. So we're going to click on Edit, Import, Download Data. Now when this comes up, yours probably won't look like this at first because you're probably somewhere else in the United States, or if it's your first time in here, somewhere off the coast of British Columbia and Canada. But what we have here is we have a base map, and you can control which kind of base map you pull down based upon the map type in this dialog box down on the bottom right. And these are the different types that you have. I'm just going to stick with Bing Hybrid. The other thing is this area is the area of our interest. This is Lake Murray in just outside Columbia, South Carolina. We're going to be pulling some data from here. To navigate around here, you use the arrows in the upper left-hand corner. The right arrow takes you to the east, the down arrow south, west, and north, and this slider lets you zoom in and zoom out. And I'm going to just zoom in a little bit more to Lake Murray, and I will slide us up just a smidge. Because we're really interested in information right in here. Now, as far as data sources go, you can download data directly from US EPA Storette, the USGS NWIS Water Quality Database, the USGS NWIS Flow and Stage Database, the USGS NWIS Real-Time Instantaneous Flows, as well as going to NOAA for NCDC. And then we have this hybrid option called Kawazi. Kawazi is a one that allows us to pull data from more than one of these network types at the same time. So I'm going to use it. And what Kawazi is a group of universities that got together to actually just put this interface around these other data sources to make it a little bit easier to pull data. The next thing we need to do is we need to set the date range that we want data. I'm going to go from January 1st, 2000 through April 6, 2013. And now we have to set our area of interest, and we do that by drawing a box on the screen. So I'm going to set my cursor in the upper left-hand corner, hold the Control key, hit the left mouse button, and draw a box. over the area that I want. Once I tell WRDB what area I want, and we're going to Quasi, it says, okay, well, Quasi has data here, so from what sources do you want to get it from? So we're going to get it from EPA Storette and NWIS daily values. Now, when it does that, you'll see that stations popped up on the screen that says their monitoring locations. The blue dots with the E or EPA, the brown dots with the N of the NWIS stations. So we could interactively say, well, okay, I don't really need this one here because it's not in my area of interest, so I'm going to shut it off. Or conversely, I can turn it back on, but we don't need that one, so I'm going to shut it off. These other ones are the ones that we need. That's fine. So those are the stations. If we want to see a descriptor of the ones that we have, they're right here. So there's our 3 EPA stations and our 4 NWIS stations that we're going to download. The next thing is we have to pick the parameters that we would want to download from these sites. We're going to go after, for the EPA data, we're going to want dissolved oxygen and water temperature. Well, we don't want all of these because I'm only interested in a couple of things. So what we can do is right mouse click and say select none, and they all get shut off. So I'm just going to turn on water temperature, dissolved oxygen. And then from the NWIS stations, I'm just going to get average dissolved oxygen and that's it. So we're going to get data for these 7 stations, 3 from EPA, 4 from NWIS. So once we have these things selected and we're okay with that, we're going to say import. And what WRDB is doing now is it's going out to Quasi and say, okay, for these stations and these parameters, I'd like all this data for this particular time range from January 1st, 2000 through April 6, 2013. And what it's doing now is it's actually downloading the data to a temporary directory on your machine. So once it comes to this point, it says, okay, we're ready to process. And say you decided that you didn't want a couple of these stations, you don't have to bring them in. But we're going to bring in all the stations. They're going to come in with these station names. And then the parameters, we're going to, I don't really want a parameter name coming in that looks like that. I'm going to convert it to, I'm going to say create new. And I'm just going to call it DO for dissolved oxygen. And then I'm going to do the correct, select it down here, and then I'm going to select water temperature for this one. Now, one of the things, the EPA Storette is storing DO in micrograms per liter. I'm not quite sure why. So we need to convert that back to milligrams per liter. So we're just going to multiply it by 0.001. So we have our stations and we have our parameter codes. So we're just going to say OK. And basically it comes back and says, okay, do you want to import and append 6 stations, 3 parameter codes, and 13,994 data observations? We're going to say okay. That data has now been brought into our... All right, now that we've seen how to import data from downloading it from the web, we're going to look at how to import data using a Excel spreadsheet file or a text file. In our example, we're just going to pull in some field data from an Excel spreadsheet. So I'm going to create a new working table for this. So I'm going to close our Lake Murray working table, click on working table, create new. I'm just going to call this one field data. Now we have a blank worksheet. Now let's just go over and look at a spreadsheet file. A lot of times you get data in this kind of format where you have stations and then a date and time and then the result of a sample. So when we pull this into WRDB, the big deal is we need to make sure that we're going to add these station IDs to the station table along with these lats and longs. This data here has got to be tagged with these dates and times And then these parameter codes need to be in the support table before we import them, otherwise it wouldn't recognize what it is. So what I did is I created a cheat sheet over here to just put the P codes into the WRDB support table. So I'm just going to copy this to the clipboard, go back over to WRDB, click Edit, paste import records, and now I just have to make sure that I point these into the right field. So I'm going to go down to the P code fields, and that's the P code, the analytical name, and then the units. So once I have all this stuff lined up, I just say continue. WRDB is looking at this data and says, hey, this isn't real data. This is going to be support code data because there are no station IDs or dates and times associated with it, but we're going to import it anyhow. So once it's done, the data is brought in. If we go over to the support table, over in the P codes, there are all of our new P codes in there, along with the ones that we created when we downloaded the data from the web. So now we're going to go ahead and we're going to pull the data in. So we're going to go back to our spreadsheet, and we're going to highlight the data that we want to bring in. And we're going to copy this to the clipboard, go back to WRDB, and just as we did with the P codes, we're going to do Edit, Paste Import Records. And now we just need to make sure, again, some important data is lined up. The most important is station. We need to map this into the station data. So this would be station ID. This would be latitude. This would be longitude. These need to be mapped into the time or the date fields. So we're going to go back up towards the top of here, and we're going to find date and time. And this is a date. This has already been picked as a time. And also what WRDB import did is it recognized these P codes as already being in the support table, so it automatically lined them up for us. So we're done. If we hit continue, the data will be imported into our new working table. So there's a total of 1,281 new records that were brought in. If we go to the support table and we click on stations, there are our new stations with their associated lats and longs. We could just check to see the data here by using one of the reports. If you do an output reports summarized by station and parameter, select all of those tables, all the records in the table, and there is our quick report of the data that we just put in. Now there's another way to get data in from a file where you don't have to use paste from the spreadsheet. You go to Edit, Import, Import Data, select your spreadsheet, pick your tab in the spreadsheet, and then this will load that same form that we had before, and we would just have to again assign the fields to pull it in. So that's basically how you get data into WRDB. Now the nice thing is, if you try and you mess something up, you can just come in here and go Edit, Delete All Records, and it'll empty this table and you can try again. Now that we've just imported our first set of data, now's a good time to go look at some of the data that goes into both the working table and the support tables. So in this working table, what we have here is we always have a station ID, which is specific to the location, a date, a time, a parameter code, in our case dissolved oxygen here. If this was stream profiles, you would have the distance from the left bank. If this was a vertical profile or a depth associated with the sample, you would have the depth here. You could have a reporting agency code, you could have a C code associated with this, or you could have like an R code associated with that. And then ultimately the result code is the actual measurement that goes into this field. So this makes up the data table. Now, how do we know where this station is we'd have to go into our support tables, which is on this tab here, and we would open up the support table, and the first table we'll see is our station table. So there's our station ID field, and these have to be unique for each individual station, otherwise the WRDB will get confused. This is the description of the name. If you had an associated station type with this, you could have that. For us, we have latitude and longitude, which is actually where these stations are located in space. And then we have the reporting agency. Remember, we did an NWIS daily and an EPA STORET, so we know where the data came from. Other fields that could be used in here is you could populate river mile. If you had it, you could have the drainage area above the station. You can have a water body type, stream, so on and so forth, the basin that it's in, some FIFS, county or state code, an ecoregion or a planning region, so you could do some screening on that. Because we have a latitude and longitude, we can actually see these stations in WRDB and its little built-in GIS tool. And real quickly, if we wanted to just see where these stations are, if we click on this button down at the bottom, Show on GIS Map, what it'll do is it'll load this other program up, and it will go ahead and put the stations out here. And actually, if we just go Layer, and we're going to just add a base map. I'm just going to use one that comes in pretty quick. I'm going to just use this hydro base map. And zoom to layer. Oh, I'm zoomed in a little bit too close. There's our stations that we pulled. And we'll see a little bit later on when we talk about the capabilities of the WRDB GIS tool. So again, what we get out of the stations table is a relationship between this station ID and the data table with their locations. The other nice thing is when we downloaded this data from the Kawasi server, all of this information was automatically populated in the stations table. The next table that we kind of need to look at is the parameter code table. And right now we only have two parameters because we downloaded dissolved oxygen and water temperature. But remember when we pulled it down from the Kawasi, the STORET, the units were in micrograms per liter, but we converted them to milligrams per liter. So we would need to come in here and change the units field to milligrams per liter. And then we would come down here and we would hit Apply. And we want this to be correct because when we go look at some of the reports in a moment, we would these units would be appropriately displayed. That's about it for now for the support table. Let's apply, and I'm going to close. I'm going to close, and I'm going to go back to the working table. The next function that we're going to be looking at is some quick ways of screening our data. There's some tabular ways of doing it, and there's graphical. The first one we're going to look at is the tabular or the reports. To do that, we're going to be using all of the data to start with, and then we can go ahead and we can query out some data to do some more detailed reports. But just to get an inventory of the data that we just downloaded, as far as the time frame, the number of observations, and the range of the data, if we just hit Output Reports and pick Summarize by Station and Parameter, and what this will do is this will build a table for each one of our stations for both the two parameters that we downloaded, DO and water temperature. So if I click that, we get a table that looks like this. So here are our stations. Here are the parameter codes that we downloaded. Remember that we changed this from micrograms to milligrams per liter, so this report is correctly. These are the number of observations for each parameter code that we have at each one of these stations. The mean, the min, the max, the first date, and the last date. And I'll show you from the NWIS station, we actually got data from a couple of days ago. So this gives us a good idea of the amount of data that we have without doing anything. The other nice thing about these tables are you can copy them, load Excel, and paste them, and then you can take them to reports. Or if somebody just wants, or if somebody just needs to have a report of what you have here, you can go ahead and create a PDF of them. Save it to a file, and there is the PDF file. Some other nice features in the output is if you wanted to see distribution statistics, you can go Output, Reports, Summarize by Parameter Statistics. And what I'm basically going to ask for is I'm going to create a report in a tabular format, show detailed information for each station. I'm going to show overall average options. We're going to show station statistics, and the percentiles are going to be based upon raw data, but we also can do it based upon means, medians, and geomeans. But I'm just going to leave it as raw data. So now we get, for each one of our stations and each one of our parameters, we get what we saw before, the number of observations, the min, the max, but we also get the mean, the median, the standard deviation, the geomean, and a percentile distribution of the observations, which is kind of useful to look at. And again, the same thing, you can copy and paste this there. At some point, we'll talk about this percent exceedance. If we actually put the water quality standards in for South Carolina for like DO, it would tell us what percent of the time the DO standard was exceeded. We'll do that at another time. So there's many different ways for outputs. So you can summarize by station parameter, parameter station. If you've calculated data, you can do it by station codes, C codes, P codes, and then of course you have the parameter statistics. You can also sort by station, parameter, C code, and also date time. The date time function is actually a very useful one because it'll actually pair data that's been collected on the same time or on the same day. In our case here, we can have all the water temperature data and all the DO data collected on the same time be paired up, and it would be very easy to do a regression analysis. And then you also can screen for custom for lab test limits, water quality criteria, statistical outliers. So there's many different ways, and I would suggest that you, once you have your working table built, you should experiment with some of these options. Okay, the next thing that we're going to do is we're going to look at how you query data or subset the data so to work with specific data sets. I'm going to be using what's called the advanced query, and you can access it from one or two ways. You can go to Select Advanced Query, or you can type Control Q, and it brings up a screen that looks like this. Now, this always, WRDB always remembers the last query you were in, which was not this project. So I'm going to delete out all of this data, and I'm going to give it a new set of things to query on. So say that we were interested in just the Lake Murray 100 meters above the dam. If we click on the assist and we just say I want this station, and I only want it for DO, instead of working with this complete table of almost 14,000 records, when I hit execute here, I'm actually down to 94 records. So this is the 94 DO observations that we have for Lake Murray here. So if I hit close, I can run those same output reports. I can summarize, again, station by parameter. In this case now, we only have one station, one parameter. There's our 94 observations, our mean, our min, our max, and the time range in which we have data. We also could go back and re-query and say, okay, you know what? I want all of the stations, but all I want is water temperature. and I would execute that, and it subsets that out to only 145 observations. And again, output reports summarized by station and parameter. So we do have temperature at 3 different stations for different periods of time. So that's basically how the query works. And the query is very, very important, because as this table gets bigger and bigger, you're going to want a subset to work with different, just smaller components of it. The next function in WRDB that I'm going to spend a good bit of time on is the time series, or the graphing program. But what we need to understand is the graphing program and the GIS tool are separate programs actually than WRDB. So WRDB actually calls these programs and sends whatever selected data to those particular programs. So in this case here, I want to send all of my data. So to make sure that I send all of my data, I want to go select, use all data, or Control A. And that'll say, okay, I have 13,994 records selected. So now, to launch the time series plots, you can either click on the icon, time, or you can go to Output, Graphs, Time Series. And this will load that graphing program. Now, this graphing program is very, very powerful, and it has a lot of features. I'm going to spend a good bit of time touching on the biggest features here. But just to show you how quickly of a utility it is for graphing, I just sent over my class example, almost 14,000 records. I can say, you know what? Let me select all of my stations, and then with my DO, I can say add to the left axis. And then for my water temperature, I can select water temperature in all my stations and add to the right axis. And I end up with a graph that looks like this very quickly. So there's DO, there's water temperature. These are my stations. You can tell by the line color and type which ones they are. We can actually zoom. And to zoom, I'm just dragging a line at the bottom. I can use these buttons up here at the top to zoom us back out. I can zoom the y-axis as well. And all I'm doing is right mouse clicking or left mouse clicking and dragging when I have those arrows in those directions. So we can zoom it around. Some other functionality that we have is on the graph options. Well, as you can see, you can control how everything looks, both how the axis, the fonts, the colors, and so on and so forth. I could add a title to my graph. And again, I can control the fonts, the sizes. I can control how my legend looks down at the bottom. But that's pretty much how the graphic utility works. Some other options that we have here is if you wanted this graph to go to Excel, you can either click on the Excel button up here, or you can just right mouse click and say send to Excel. And this data is dynamically passed to Excel. There's our graph. This is the same graph that's in WRDB. And here is the data that went into that graph. So this is a useful tool if you needed to do some other statistical analysis. Same thing, you could do send to a PDF document. Oh, not implemented yet. Sorry. Or you can send the image to the clipboard. Send image to the clipboard. And then you can fire up a program like Microsoft Word and paste it in. And we'll look at some other ways to do that. Some other plots that you can do is you can not just time series, but you can do a scatter plot. In this case, I'm going to choose below the dam, Saluda River just below Lake Murray, where I have DO, and I'm going to put DO over here. Now, because this is a scatter plot, I'm going to have DO up on the Y, but then I'm going to ask it to put temperature on the X. And there's our scatter plot. And it shouldn't surprise us as the water gets cooler, the DO goes up. Another thing that we can do is we can do probability plots. And in this case here, I'm just going to select DO, add it. So this is a probability plot of the concentration at time. So our 50th percentile DO concentration is like 8 milligrams per liter. Another good way to look at whether or not it's meeting a water quality standard. Because say that South Carolina's water quality standard for DO was no less than 4 milligrams per liter 10% of the time. We can see that 10% of the time it is about 2.5. So that's some of the interesting things that you can do with graph. Now there are some really powerful features in here, advanced features. What I'm going to do is I'm going to remove all these tabs right now. And I'm going to go back into, I'm going to click on series, and I'm going to use these build functions down here. And we can build them a couple of ways. We can build multiple tabs by station and P code, or just multiple tabs by P code. So if I selected it multiple tabs by station and P code, what it's going to allow me to do is create a time series plot of DO for Lake Murray, for the first station, the second station, so on and so forth. I can automatically put a title on here. I can ask for summary statistics, which we'll review in a second, and I can say OK, and it's going to tell me we're going to build 12 series, and if it runs into a station that doesn't have data for every one of them, it's just going to tell you, hey, there is no data. That's no big deal. We already knew that from our station parameter summary list. So here's our stations. Water quality at Saluda River, or water temperature at Raw Creek, so on and so forth. So there's going to be a total of 12 of these here, going all the way back to the beginning. So real quickly you can build these graphs. Now we're going to be using this graphing tool when we get to the WRDB's use with models. We're going to be using it very, very extensively, but the basic premise here is it's very, very easy to process this or plot this data once you have it into the data tables, into a working table, and you can bring it over here. And again, just like I said with the output reports, you should investigate on your own all the different functionalities that this program has, because it has many. To leave the program, just hit the X and say, if you say yes to this, it's going to ask you to create a file, and I'm just going to call this class example. You got to pay attention to where it's being put. I want it to go into my project directory, WRDB class examples, and it's saved. Now, one of the things we could do is if we go back to the graph, we can hit close on this, and we could just say load last, and all of those graphs will reappear. Also, what we could do is from Windows Explorer, we could go to this directory and if we just double click on this graph file, we get the graph back as well. So very, very powerful tool. And again, you'll see that a lot as we work through this. So the next function that I'm going to show you in WRDB is its ability to calculate data from data that's in a working table. And what we're going to do is we're going to calculate the DO saturation, concentration, the percent saturation, and the DO deficit, or the difference between DO measured and the saturation concentration. But before we do that, we need to create a couple of P codes to store this data in. So we're going to click on the support table, parameter codes. We're going to go to the bottom and we're going to type in DO sat, and we'll just call it dissolved oxygen saturation, and that's in milligrams per liter. Then we're going to do per DO, which is percent DO sat, and its units is percent. And then lastly, DO def, which is DO deficit, and it's in milligrams per liter. So we have these new P codes because we're going to be storing our calculated values in there. So I'm going to say apply and close. Now, what I want to do is I want to go find stations where I have paired data. So if I go to Output, Reports, Summarized by Station Parameter, we're looking for a station where we have both DO and temperature. And you can see that we have it for a couple of these stations. I'm just going to make the calculation for this one, Lake Murray, 100 meters west of the dam. So what I need to do is I need to select this data for both DO and temperature out of the working table so I can make the calculation. To do that, I'm going to use a query. I'm going to do Select, Advanced Query. I'm going to hit Assist. I'm going to select that station that I want. I'm going to say OK and Execute. So now I have 188 records. If we go back to that same report, it's going to show us that the only data that we have active to work with right now is Lake Murray 100 meters west of the dam for DO and water temperature. So to make the calculation, we're going to go to Edit, Calculate. And you'll notice in here there are several different calculations that could occur. We have Calculate New Data, so we can calculate new data from the data that we have. We can aggregate in space and time. Of course, DO saturation, we can calculate loads, trophic state index, water quality index, and actually do low flow analysis. So like if you pull the USGS gauge, you can actually do, XQY analysis for flows. Like if you want to know what the 7Q10 flow was for that gauge, you can calculate it. But for right now, we're just going to do the DO saturation. And you're going to get a form that's going to lead you through this thing. It needs to know what is the parameter code for dissolved oxygen, and it is DO. For water temperature, it is water temperature. Now, for the oxygen saturation, we're going to want to pick the P code that we created, dissolved oxygen saturation. We want the one for percent saturation, and then the DO deficit calculation. Whenever you make a calculation at WRDB, it's going to make you create a C code. And the C code is a way of you identifying in the data set whether this was data that you downloaded or imported from another agency or it was calculated. So in my case here, I'm just going to create a new one, and I'm just going to call this Cal for calculated. This way I know when I look in this table, I know that it's calculated. The other thing is I have the ability to store the data in this table, or I could actually create a new table and store it in there. I'm just going to let it come into this current table. So with all of this stuff selected, we're going to hit Next. And what it does is it makes the calculations. It pairs the data up and calculates out the saturation percent sat and DO deficit. And when you say Finish, what it's going to do is it says that you're about to put 282 new records into this database. I'm going to say yes. So now, if we click on Output, Reports, Summarized by Station and Parameter, so we're going to select all, we're going to see that we now have the DO deficit, the DO sat, the percent DO. And we actually could go over to the graphing utility, and we could, for our lake, plot. We could put DO, DO deficit, and DO sat on the right axis, and then we could put percent on the left, and we can see the data that we just calculated. So you can see what was calculated. That the black is the actual DO, the green is the percent, DO saturation, so on and so forth. So that's how you calculate data. Now, just to summarize some of the other stuff, another really nice one in Calculate is this aggregate data, because it has a lot of neat ways to aggregate. You could do arithmetic means, geomeans, medians. You can total for rain. You can aggregate over hours, days, weeks, months, calendar years, water years, climate years, growing seasons. You could use a 4-season calculation to make its calculation. You can also aggregate in space, where you can add stations together. So it's a very, very powerful tool. The other Calculate that we could look at is we can look at the annual low flow, and I can't do it right now because I don't have one station selected. So, and we'll do that calculation in a more advanced WRDB session. The last tool I'd like to show in WRDB in this first session is going to be looking at the GIS component of WRDB. The GIS component of WRDB uses a open source free version of Map Window, which is a very capable GIS tool that's going to allow us to do some pretty neat things quickly here. So again, I'm going to make sure I select all of my data, and then I'm going to go Output GIS Maps, and we're going to come over here. Now, this doesn't look like much to you right now. I'm just going to zoom out just a little bit. Now, the first thing I'm going to do is I'm going to add a base map, and we can get anything we want. I'm going to just get Google Satellite. And then I'm just going to zoom back into my, and you zoom just like you do in ArcGIS. You highlight the layer that you want, right mouse click and say zoom the layer. So there's our stations in regards to the Lake Murray. The dam is right here. This is the Saluda River. We can, if you wanted to just see what the average DO values are for the period of record, you set these up at the top. Use your selection tool, and if you hover over the dot, you can see down here in this yellow area, there's our station 100 meters west of the dam. The average is 8.7, and you can keep moving down until you get down into the tail race and see that. Now, one of the other things you can do is you actually could come in here and you can select these stations and hit the graph button, and there's our time series of graphs. You also can, if you're only interested in comparing DO at this station and this station, to see how much has changed from the coming out of the tail race to down the Saluda River. There's our graphs. Unfortunately, we don't have a lot of data at the same time period. But the tool allows us to do a lot of different things. The other thing is, if you have your own GIS coverages, you can include them into here. So, like if we had a water quality model set up on Lake Murray, we can have our WASP segmentation or our EFDC grid be displayed here. So the GIS tool is a nice way to look at stuff so you can relate stuff in space. We can also go ahead and look at water temperature, see where we have water temperature data as well, and still hover over it and get all of that. So this tool is got a lot of capability for doing some assessment. Depending upon your imagery, you can probably, you can zoom in here pretty good to see where we're at with the monitoring stations. So this tool again allows us to look at our data in space. So very, very useful for doing assessments.